So behind us we have Organism and Excitable Chaos, which includes two different works and they're coming together as one, as an installation. In the back we have Organism, which is an organ that has been media-archaeologically relooked at. And in the front we have Excitable Chaos, which is a triple pendulum that's robotically co-steered. In the installation mode, Excitable Chaos's movement drives Organism's thresholds of airflow, so we hear the sonification of chaotic movement through fluctuations of air that Organism turns into sound. In the concert mode, there is no pendulum, and I engage with Organism gesturally. That's that. So let's talk about Organism. In 2016, the second oldest church in Montreal was going through gentrification. I was invited to look at the site and activated media archaeologically, looking at histories of the site. However, the gentrification took over, and soon the venue became a gym and a wedding venue. I took this as an invitation to think of the organ as the site where the turbulence of nature is stabilized and conquered to impose 12-tone ideologies upon it. And I was able to borrow the pipes from the site. And shortly after, I was joined by my collaborator Garnet, Willis, and together we looked at the organ as this media-archaeological project, unearthing ways in which its turbulent materiality has been dampened throughout history, so it could have an ideological stability. However, the goal became to look at ways in which the organ's sonic thresholds are alive if we let it be. What does that mean? Each pipe is a universe where if we don't give it a stable flow of air as designed by the original organ maker, it could go between tone and timbre and noise, and it could sound all sorts of lively modes of mattering. For example, subtlest fluctuations of air result in rather dramatic shifts and discontinuous shifts of timbre, tone, and loudness, which is a property of nonlinear dynamical systems, because when we have laminar flow pushed through against an edge, the air curls onto itself, and turbulent patterning and laminar flow and vortex all locked into dynamical unity and result in a complex behavior. This all has been stabilized historically, so we could get a very clean tone. However, as you heard, this can be re-enlivened. Now imagine the liveliness of this one pipe times 60 pipes, as we see in Organism, where the threshold pushes and pulls of air affects the other. What emerges is an ecology of interdependent timbres. So Organism is the becoming organism of the organ in that sense. It's becoming alive, it's coming to life. And in concerts, it feels like performing with agencying of an unfolding turbulent wave that I try to stay afloat, holding moments of timbral magic and creating textures. The music that comes out might resemble all sorts of cultures as reported to us by audiences. However, that's not the intention, because when composing with Organism, there is no ideologies musically coming from us. There's no notes, scores, only modulation of energetic thresholds. But technological control over turbulence of nature is the process that's responsible for becoming cultural of nature, sonically in this case. So when that process is open to becoming anew in context, all sorts of musical cultures can emerge. to go beyond idealization of nature and mathematizations of nature, which are generative algorithms of today, from AI, music, to stochastic formalisms of sorts, are an expression of, to go beyond that into the kinetic rawness that gave birth to that once. So the simplest place in nature where a faint source of liveliness emerges is a double pendulum. A double pendulum is a simple nonlinear dynamical system where the exchange of potential and kinetic energy between the two oscillating arms, or movement bound between two limits, leads to the emergence of a dynamical unity, and their forms of coming together and exchanging information and falling apart leads to an inner liveliness. The art science question that was at the focus of our investigative process was to find and ask ourselves, what is it of chaos that feels alive? This is not a question that positive science can answer, as we've seen positive science failing at describing what is alive, what is consciousness. So we grounded ourselves in a methodology that's not just conceptual, but also thermodynamically informed. When things come together to exchange energy, and when a system is put into tension with itself, it has energetic tensions that it needs to internally resolve. The moment this happens, the system to a degree no longer is abiding by the linear causality of the outside world, be it entropy or physics of movements, because now it can resolve its tensions internally. This is a faint sense of sense developed in nature. It's nature's engine of invention, and it's a faint sense of intentionality. It's a system that is in tension with itself. In its intensity, it can develop intentionality, which means a directionality within its dynamic unity. That makes it the system's excitability. So the question for us becomes, methodologically and ethico-aesthetically, how can we modulate the intentionality of the system without dampening its form and manner of liveliness? So therefore, combining technology with nature's liveliness is both an ethical, aesthetical, political, methodological, technological, investigative problem. In positive science, the triple pendulum is known as the three-body problem, as popularized. For us, however, the obsession or the aesthetics is not about sensationalizing. For us, however, the issue is not sensationalizing aesthetics of indeterminacy and its surprising outcomes that's been done throughout history. The more pressing and interesting issue is how we could collaborate with this liveliness. So therefore, it's a three-body no problem. If we were to embrace its generative liveliness. This way of thinking invites us to reverse our obsession with conquering, controlling nature's wildness and embracing its otherness in its unpredictability. But as we explained liveliness, anytime a system is alive, has a faint sense of intentionality, it's also indeterminate. So these two things always come together. So the work's investigative background is an invitation to embrace otherness and other forms of liveliness and to collaborate with them. I will add really briefly now what the coming together of these two sculptures does. So in the front, we're steering the form of liveliness of a dynamical triple pendulum. Each instance of its modulation, which means the relation between mass and orbital relations is pivotal joints, is an instance where it's an ecology. For example, think Miami versus Alaska. Each is infinitely variable, yet each is very distinct. It has a distinctness as each person or each ecology is. So we're able to take the system to modulate this ecology to go towards one or other modes of being, but then let it generate. Now, real-time sensors within each arm sense the movement of each arm and map it to organisms' turbulent thresholds that modulate the flow of air into each pipe. But as we know, organism itself is alive, so it's not a one-to-one mapping. So this becomes a sonification project. However, it's not a scientific sonification project, it's an art science sonification project. What separates it from a typical scientific sonification project is that we're asking at every instance again, what is it about chaos that's alive, that feels lively? Therefore, when we extract movement, we avoid idealizing it. As we've learned from philosophy of movement, from Bergson to Simondon, etc., we have to avoid spatializing movement. So we try to look at the intensities that are developed within the system that lead to the emergence of its dynamic unity. This means its energetic tensions and their resolutions, upheavals that lead to phase shifts, its manners of expanding and contracting, turning, vorticity. So these qualitative forms of movement that to us, both intuitively and investigatively, explain the manner of life of this chaotic motion of excitable chaos are mapped to organism. The result is a meditative platform for sonic investigation for the audience into how chaos and turbulence generate faint sense of sense, or faint forms of liveliness in nature, both for pleasure of listening to it musically, as well as for an investigative deep listening into ways things come together and fall apart.
I'm very interested in what kind of subtleties need to be explored in the world of analog generation that allow the resolution of the world of analog to be the butterfly wings for future processing. What tends to happen in most digitized systems is that in between one number and the next number, there's empty space. And in that empty space between those numbers, anything can happen in the real world that we live in and experience. But that is not measured by the device. Whereas in an analog system, everything at all orders of magnitude are transduced. And some things get dampened out by mass relations and certain types of energetics. But so our interest is in the kind of subtle refinements of energetics that can produce outcomes or digitally measured system. For example, in the organ pipes, Navid was mentioning the dynamic unity of the pipe, and we're very interested in producing timbres and irregular aspects of the sound of the pipe that are anything but the sound of the church organ. We feel like the church organ has been engineered over the centuries to produce this kind of sonic purity, and that sonic purity is only 1% of the potential sounds that can happen in the pipe. The other 99% of them just want to be free. And so our approach has been to look at each pipe, experiment with it, play with it, and find out what is it about this pipe that has some kind of magical dynamic properties. And there are some pipes that we have experimented with that don't have much flexibility. They just want to be church organ pipes. Some other pipes are crazy, right? Okay, this one's got magic in it, because we can then say, okay, by modulating the airstream that comes into it using modern technology, and that's where the digital aspect of this piece comes in. But to us, the value is, how do we change the stream of air going into the pipe so that we can capture this 99% potential of all the sounds that those pipes were never allowed to play in a pipe organ, right? The thing about the pipe organ is that it's a very controlled technology. We're using these antique pipes to kind of liberate them, to be able to produce all those sounds that they really haven't been able to do, and maybe the organ designers are twirling in their graves as a result, but times change, right? So on the output, this is the palette of sound. This is the paint that's on the canvas. We're very interested in the way that we can harness the turbulent activity that happens inside the pipes to produce a wide range of sonic outcomes, and then we select the pipes that we use in the piece because they're the ones that are the unstable ones. They're the ones that were once the problem for the organ designer. It's like, okay, we like this pipe. This pipe is going to have all kinds of flexible, rich sounds that are always a little bit different and maybe a bit confounding, because one day it might be a different sound than it was the day before. These kinds of instabilities are existing in the kind of subtlety. And the subtlety of that is humidity might change it, or temperature might change it, or just any small thing in one day might produce a different result the next day with exactly the same conditions that we give to it as far as we know. But the world is porous, right? And the porous world comes into the pipes and says, oh, today you're going to get this range of sound, right? So that's on output. On input, we wanted to have a system that we couldn't predict what it's going to do. So we started with a little test pendulum, one that had like manual slides. I could get a screwdriver and slide the points of balance between the pendulums, and we could just swing it by hand. And there was a period, Nav, of about 6 months when we just swing that little pendulum and watch it and adjust it, and then swing it again and watch it and adjust it. And it became apparent to us that there are certain sets of mass relations between the three pendulum arms that generate very interesting and subtle outcomes. They have a propensity to have a strange attractor rather than a periodic attractor. And it's okay, look, if we do this, and we put them here with a little mark on the side of the pendulum saying, okay, this is A, right? And then we would like readjust it a little bit and swing it, and we find, oh, this one is also chaotic, but it's a different relationship in terms of the different frequencies and propensities of the mass relations to relate to one another. So it's like a different, I like to call them families. Navid doesn't like the word family, but in any case, it became apparent that with this little pendulum, we had discovered these kind of, okay, I'll call it modes of chaos, right? Each mode has a set of propensities built into it, but within the details of those propensities, there's chaos. And I think that this type of propensity to have a chaotic system is really at the heart of most generation in the universe. I think, this is my personal opinion, I think most materiality is generated by chaotic activities that snap into some kind of a stable form, and then they exist. And so we're really working this pendulum to find mass relations that are going to generate the most interesting outcomes over the long haul. And Navid said, three-body, no problem. Okay, well, in theory, three-body, no problem is no problem, except that then you have to build a three-body pendulum that can do all of these things, have different modes of chaos, be able to change from one mode to another as it's swinging, have to be able to overcome entropic losses in the system. That is what happens just because of friction in the bearings, air friction, all these things that cause the energy to be lost. And so we came up with the idea of having a hybrid motor that only replaces the energy that's lost to entropy. It also can be used to embargo energy to the system, and we get different outcomes because the way the energy is shared within the three arms of the pendulum as they swing is determined by the amount of energy that we put into it. If we put too much energy into it, we're controlling it. If we put not enough energy into it, the energy concentrates in the higher frequency components. This is what we see with resonance in general. Came up with this motor that knows what direction it's going, and it knows where it is at all points. And then just like with a swing, we just give it a little push on each swing, and we only push the big arm. The two smaller arms are always free hanging. So they're just there to rotate as they will based on the mass relations between the three arms of the pendulum. And so the system that we are scrambling chaotically has its inherent energy introduced by the chaos motor, which is only two, one on this pendulum and one on our research pendulum. The idea being that if we add energy at the point where we have the most velocity already, then that addition of energy is less likely to dominate over the subtleties of chaos than it would be if we introduced energy at the least amount of velocity, in which case we're overpowering that small amount of energy. And what we want to do is we want to farm and amplify the subtle amounts of energy that cause the state to continue its changing dynamic behaviors. Came up with this motor idea to drive the pendulum only at one spot in the arc, but also we didn't know this at the time, but later on we learned that if we change the amount of energy into the system, not just the duration of time, but the amount of physical current that's used by the coils, it affects the way in which the arms relate to each other. This is, I think, a new finding. It's interesting because the energy is always shared, but who gets it right? Which arm gets it? Well, we don't know because it's the three-body, no problem, right? And the other aspect of the piece that has been difficult to overcome are the structural and engineering aspects of it, but also how is it that we can have a minimum amount of friction in the system so that the friction is not always dampening the subtle energy that we want to be able to manifest through the system. And so there's a lot of basically mechanical design in the system to like really eliminate mechanical friction within the system. And then of course then there's the thermodynamic aspects of heat versus energy. And so we also had to figure out how many coils do we need and how can we have the system run in a way that it won't, first of all, cause the pendulum to fly apart because of too much energy, but have it at a size that's adequate so that it runs at a good temperature, but also doesn't burn up, right? We don't want to have the coils burn up. We want to have the system kind of just right in size of magnitude so that we can introduce the lost energy. And in fact, we modulate the energy depending on how much each mode of chaos, how much we figure it might need. So at both ends of organism and excitable chaos, we're looking at this kind of necessity of analog subtlety, and that subtlety is the thing, that's the butterfly wings of the system. And often that subtlety, I think, is falls between the cracks of numbers in digitized systems, right? And so having a physical, material computation system to calculate the chaotic behavior differentiates it from any kind of digital calculation system and all of its rounding errors that happen between the bits, right? So for example, if I was sampling a wave and I had a sample here and a sample here, the assumption is made that it's doing that. But it could do this in between, right? And the only way that you can capture that in between is, well, up your sample rate and up your bit depth, or create a physical system. And the benefit of creating a physical system is that it relates to us corporeally. The size of this pendulum is kind of within the range of the way a human body sways. And the earlier prototype pendulum was about this big, and it was like a baby, and it was kind of, it was almost too frenetic for an adult human body to relate kinesthetically to. And we wanted to build a bigger pendulum with presettable mass relations so that we can go very slowly, and so that when you're watching it, you can sort of feel, you know, the motion, because it's within the same order of magnitude of the way a human dancer would sway, right? And so that was important because what we're aiming for here is an engagement between human experience and whatever we encounter through the work. Getting it framed just right so that in the timeline of the experiencing of the work, a correspondence to people's phenomenological reaction to the motion of the pendulum and the ways in which the organ sonifies that. And I think also, interestingly, that our intention with respect to the sonification has always been to do nothing but sonify the current data, right? So we don't add anything, we just take what's coming from the pendulum and use that to orchestrate all of the pipes and their turbulent outcomes in the organ. And so with each particular mode of chaos, we would say, what is it about this mode that feels right in the sound? And if it didn't feel right, we'd just not do that. And so we come up with these orchestrations that are, I guess, suitable within the turbulent outcomes of the organ, with respect to the way that Navid and I would feel about the way the sound wraps the pendulum motion. That's it.